Hey everybody, good afternoon. Thank you for joining. It's a good afternoon from where I'm speaking from. I'm joining here from Dallas, Texas, and welcome to my session. It's going to be a brief session on introduction to controls engineering. And I have been in this space since 2017. So I've tried to gather some of that experience and put it into a presentation to introduce this field and, walk through what kind of, does a day-to-day look like for a controls engineer and how you could possibly pursue this field as well. I see a chat here from Tapaswini. Hey, thank you for joining, and I'm going to get started. Please excuse my voice. I'm still recovering from a real bad sore throat that I had. But hopefully you enjoy the session, and let's get right into it. So, in the next 20 minutes, I am going to go through a super quick personal introduction. I'm also going to talk about exact definition of what does a controls engineer do, what does a typical workflow for a controls engineer look like, and then I'm going to talk about some of the skill sets that you can start acquiring or start looking into to continue pursuing controls engineering if this seems like something you're interested in. All right. So let's get into the personal introduction that I have put up here. I hope you were able to get a glimpse into my bio before you joined the session. My name is Apurva Bhagali, and like I said before, I have been working as a controls engineer since 2017. In December 2016, I graduated with my master's in electrical engineering. I attended the University of Texas at Arlington to get that degree. And ever since then, I have been with a couple of employers, and my current position is my third job actually since graduation. All of my jobs, my employers changed, but my nature of job remained the same. I have been working as a controls engineer, and my projects varied from different industries, but they were primarily industrial automation projects. So I did projects from, the dairy processing plants to the material handling systems like your UPS and FedEx projects where huge conveyor belts were involved. I was able to work on a large scale project that involved dairy processing. And finally, now I have taken up a position as a hardware engineer with Microsoft, and I am working on their data center monitoring and controls engineering team. So my nature of work has changed a little bit since joining Microsoft, but I'm primarily drawing from my experience while working with systems integrators to talk about controls engineering today. All right. So, like I said before, I am going to do a brief introduction on who is a controls engineer. Um, Controls engineers primarily deal with industrial automation projects. And if you look at the term industrial automation, automation is basically ingrained into all sorts of industries around us. Primarily, controls engineers can see different projects in their domain from different industries like the material handling industries, the manufacturing industry. It can even be the dairy processing plants. It can be air handling systems. It can be robotic systems. So industries around you that require automation lines, such as conveyor belts running, robots working to assemble products, or it can even be some kind of testing that is done during, in an automated manner. So all of these fields would require the contribution of a controls engineer. Apart from working with software, which is a primary tool that every engineer uses today, a controls engineer deals with a lot of hardware. Now, for a controls engineering job, hardware and software go hand in hand. So when I talk about hardware, there I have listed a few typical hardware that a controls engineer might interact with on their day-to-day work. It can be hardware like PLCs, which stands for programmable logic controllers. It can be HMIs, which stand for human machine interfaces, or basically screens that operators interact with. The screens can depict the plant status. It can depict the status of the machinery around. It can depict certain different statistics about the products that are being manufactured, etc. So these screens are a vital part of any controls engineering plant that is employing. Different hardware also includes drives, motors, VFDs. Basically, a controls engineer will interact with a lot of hardware that actually controls the motion of the mechanical devices that may be, installed in the plant. So it can be huge conveyor belts. It can be, interacting with temperature sensors, humidity sensors. It can be interacting with different motors that's controlling motions of robotic arms, etc. So that's the typical kind of hardware that a controls engineer deals with. I already went through the different kind of industries that a controls engineer may work in, and I have taken the fifth point here as that a controls engineer may work as a desk job or as well as an on-site job. By this, I mean that a controls engineer may be primarily involved with development, which is done in an office environment, or he or she may also be involved in the on-site job, which actually is dealing with deploying the work that's being developed in-house, deploying it to the actual hardware that's present on site. And both of these duties may be done by the one controls engineer as well. So please feel free to type any kind of questions you may have during when I'm speaking. I will try to address them in the chat. All right. So moving on, the reason that I have this next slide prepared is that since my talk was going to be aimed for individuals looking to get into controls engineering, I wanted to give you a good highlight about what are some of the keywords or what are some of the positions that a controls engineer is addressed by in the industry. The reason I thought this slide is super essential, it's because when I was trying to get into this field after completing my master's degree, I did not know what to even search for when I was trying to apply for a job. So basically, I wanted to make sure that I don't harp on using the word controls engineer too much, because in the industry, controls engineers are also referred as systems engineers, automation engineers, process controls engineers, and some of the other terms that I have listed here. I think it would be, really useful to note these down, and they will prove super useful when you're trying to look for a job. In your job hunt, when you kind of want to search for open positions at different companies. All right. The main motive of my next slide is to go ahead and speak about the typical workflow that a controls engineer actually goes through in their day-to-day work. This kind of workflow may last for several months. It may last for several years, of course, depending on the kind of project that he or she is working on. So the very first step for a job to commence, for a controls engineering or an automation job to commence, is requirement gathering. As with any engineering job, it is essential and vital to know and fully understand what the project is set to achieve, what is the end goal, what is the kind of automation that is expected by the client that you're taking up the project for. And The requirement gathering also involves not just understanding the project fully, but also it may also involve traveling to the site to do a survey. If it is a new site, going down there and surveying where equipment will be installed, trying to understand the layout of the entire plant, trying to look at the make and model of the hardware that's getting installed in the project. All of this is a part of requirement gathering. It also involves studying data sheets for different kind of hardware that's going to be installed to make the next steps such as programming and designing easier for the controls engineer. Once the entire project has been understood, once the end goal has been clearly defined, the design phase comes into action. Now, the design phase would typically involve either programming, which is the next phase, of course, like I have mentioned here, but it can actually involve, designing the project on paper. By that, I mean electrical drawings may need to be generated, where typical layouts of the plants will be finalized, where the typical positions of the hardware will be finalized. The typical network topology will have to be finalized before all of that can be programmed. So the design phase is typically related to multiple electrical drawings, network drawings, hardware drawings, connections, physical, make and model, fixing the make and model of the hardware. Now, the design phase may or may not be done by just the one controls engineer. All of these phases are, of course, efforts of a team of controls engineers. You would not be expected to excel in, all these domains. There are specializations to, kind of excel in understanding network better, or understanding hardware design better, or understanding the layout or the efficiency of the hardware that we are going to be using, all of that. So when I am trying to, talk to you guys about what are the different responsibilities of a controls engineer, it may or may not mean that one person does it. It's a team that does it. And, if you decide to pursue this field, you may find yourself excelling at one particular area within controls engineering. Now, moving on. Once the design phase is completed, we move on to actual programming. Now, programming is a part where the hardware that has been finalized, that needs to go on to the floor and do the job, it needs to be controlled. All of this control comes through PLCs, which is programmable logic controllers, where you can hard code a PLC, through different softwares for it to control your hardware. For example, you can program motors to make conveyor belts go faster or slower. You can control sensors to start and stop a particular piece of machinery on the plant for you. So all of that programming phase is where all the software that is particularly going to interact with the hardware is used. We are going to program the software, do multiple test runs or simulations. The part that I had mentioned earlier, where apart from PLCs, you have HMI screens that are a part of some of these huge, large manufacturing plants that, convey statuses of the hardware that's being installed, or they convey the statuses of the health of the product that is being produced. All of the programming of even those screens comes into question here during the programming phase. So you program your hardware, you program your screens, and typically programming is a larger phase in the project, as expected. Once you program, you of course need to test the development that is going on. This may be done, at the complete end of the programming phase. It may be done during bits and pieces where the program is being developed in phases and it's being tested out in phases. And all that is a part of the planning and the design phase that goes on, where you need to plan how to program and how to test it. But definitely before the entire development is, commissioned on site to the actual hardware, you need to test it. And this may sometimes be done in house through the use of a simulation, or you may also be required to travel on site and test it on some part of the hardware being installed. After your testing is done, is my voice audible? Alrighty, I'm going to continue. Hopefully my voice is back. So after the testing has, all right, great. After the testing has been done, the next part of this process is to actually commission this testing. The word commissioning is heavily used in the industry. It's a word that's been associated with actually deploying this product on site or in the field. Generally, software engineers, refer to it as go live, or different kind of terms that generally other engineers use. But commissioning is something that controls engineers use heavily, and it would mean deploying the product on site. So it would mean actually downloading the program to the PLC, which is installed on site, actually running the entire equipment, controlling it through the PLC, controlling it through the screens, making sure that your screens are interacting and showing the correct statuses of the hardware. And typically, this is, sometimes a time sensitive step, because it may be done on a, you may need to deploy your product on a site which already has equipment running, and there's just some new equipment being added that you're commissioning. Or it may be a scratch, it may be a project that's been done from scratch for a new site. So this phase is typically a tedious phase. I have been in projects where I have had to deploy the programming that was done within a span of 4 hours, make sure that the project worked as expected, make sure that the hardware on site was reacting as expected, because it was a project that was being, it was a project that was expanding the current facility. So they could not keep the equipment down for too long, and it all needed to start up and fire up at the same time and function. So commissioning is a project, is a phase in the workflow that is also long and tedious, time sensitive at times, and it requires a controls engineer to think fast, act fast, kind of fix problems on the go, and make some changes on the fly, and make sure that the hardware functions as the software is written to. Once the project has been commissioned, and the project is at the end stage, and the results have been achieved, a controls engineer also needs to provide support for a certain amount of time to make sure that to make sure that the project is functioning as expected, and there are no more troubleshooting required. Sorry, excuse me. So that is the typical workflow of a controls engineer. Like I said before, each and every phase may be completed by one controls engineer. It may be completed by a team of controls engineers who specialize in a particular phase and their expertise. But This is what encapsulates the life or the job or the profession of a controls engineer. So I hope I was able to convey it. I know I wasn't speaking with a particular example, but typically industrial automation projects do work in the same flow. So the next thing that I wanted to talk about is I, kind of touched base upon who is a controls engineer. I touched base upon a typical workflow for a controls engineer. And now next, I wanted to actually talk about getting into controls engineering. So, pursuing controls engineering, since my experience has been for a few years now, I have generally seen graduates with a double E degree or an or a industrial engineering degree that are part of this field. Um, like I have been mentioning, you can have a knowledge of either hardware, software, system design that can get you into this field. So when I say hardware, you could be knowledgeable, or you could be an expert in a great understanding of the devices and wiring and different kind of sensors and PLCs and actual hardware drives and motors that perform and can give the expected output. You can have knowledge about creating specs, creating network architectures, creating test plans, and kind of project managing a controls engineering project. Or you could actually have knowledge on the software development part that goes into controls engineering. So, developing the HMIs, developing the code, testing the code, developing functions and simulating the systems. So, pursuing controls engineering can be broken down roughly into these three areas, which you might find yourself interested in, and that could kind of get you into these kind of projects and into this field. So, in summary, I wanted to kind of, put it in bullet points here that it's usually double E and IE graduates that are a part of this field. A general controls engineer deals with PLCs, HMI, different kind of hardwares. He or she also deals with a traveling job as well as a desk job. And on the right hand side here, I have tried to note down some of the challenges that come with this job. I have seen typically very, very few women in this field, which is why I take it upon myself to speak at any chance I get to talk about this field more and share my experience to make sure women are comfortable with this field. They get to know more, they get to know the intricacies that go into this job, and can see that if it is a good fit for them to pursue. Apart from that, the job is very rewarding. Sometimes, like I mentioned earlier, there's some time sensitive deliverables where it can get intense, but overall, the job is rewarding. The applications of industrial automation are, a lot. As you all must be aware, automation has taken over all sorts of industries around us, which makes this job extremely important and extremely contributing to the different projects that are happening around us. So that was all I had to share. I would love to connect further for any kind of questions about this. I tried to put this into a 20-minute talk to make sure that the word or my introduction to controls engineering gets out, and kind of I wanted to speak about this field in brief. It has a lot more. I can speak about very specific things if there are some specific questions. I am sharing my personal email here if you would like to get in touch. And I have also attached my LinkedIn link in the chat here. With that, I would like to sign off and say thank you for joining and giving me your 20 minutes. And again, once again, excuse me for my voice, but it was really fun to share a little bit into my day to day life. And I hope that I was able to get the word out there about controls. So, thank you, everybody. Take care and enjoy the rest of the conference.